Very good morning to all of you. So thank you for coming today. And I'm CK, so I'm the technical consultant from Microservices. So it's my pleasure to share with you the journey of being a cloud native today. Right. So before I begin the session, let me share with you some of the things that we always discover when we engage with different agencies and different customers. So one of the very common questions or common requests that we receive from customers is that, oh, I need my application to become native. And then some also say that, oh, I need to use all the cloud native services, or my system need to be containerized. So I always ask them these questions. So what is your intention of getting all these requests over here? Why you want to utilize or you want to tap on the cloud native services? Is it because you're just following some trends? Or is it because your management asks you to do so? Or actually you want to leverage on the true benefit of being cloud native? So, what does it mean to be cloud native? Well, different people may have different perception of cloud native. But for today, we will share with you our own experience of what is being cloud native in terms of how we design the application, build the application, and run the applications. Well, let's say you have currently have some system that's on-prem or on GCC, but you migrated to GCC cloud. So, well, I'm on cloud now, but does it mean that you are cloud native? Well, you are already on the cloud. You may not be, may and may not be cloud native. So, you may not get the true benefit of it. So, let me share with you today some of the things that some of the people think what's cloud native. I think this is a very familiar kind of setup you see in all the Facebook or some web page. So what are the developer thinks of being cloud native? Well, maybe some of the developers just think that I just need a few easy tools. Then all the things are in the cloud, so it's cloud native. Yeah. Maybe for developer that's what they think. I believe not all people think that way. And of course, maybe managers they don't really understand the concept. They just think that oh, you're doing migration, so you might be moving the server from one place to another place. Then he's doing a cloud migration. Or how about customers? Oh, as long as I'm on GCC, AWS, Azure, or even Google Cloud, I'm cloud native. And then what my friend think I do, especially those friends that's not in the IT, they think I'm just writing a label class, flying around, yeah, that might be cloud native. And my parents see that I got a lot of Amazon webpage. They think that I'm doing shopping. Well, what I really want, or I believe every one of you we really want to become native, is to be able to enjoy the benefit of becoming native, so that you can have a very peace of mind, relax, and good holiday without any worries. Right? Let's pull back more to the technical definition of cloud native. Anyway, this definition is not created by me, it's from some official source. So that way it's a bit long-winded over here. Let me read it out to you. So a cloud native technology empowers organization to build and run scalable applications in modern dynamics environments such as your public, private, or even hybrid clouds, container service message, microservices, immutable infrastructures, and decorative APIs exemplify this approach. Basically, this technique enable a loosely coupled system that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes quickly and predictable with minimal time. So this is the definition by the Cognitive Computing Foundation. Very lengthy, isn't it? But do not worry about that. We'll basically run through all of these in a different way to give you a better understanding of how to design your application in a cognitive way. Well, very pretty much like agile. The cloud native itself is not a hard requirement specifications. Rather, it's more like a mindset shifting. So you can treat it as you need to change your mindset, the way that you see application being built, the way you run your applications. So doesn't follow a hard set of requirements, but it's more like how you view it. It's a mindset change. Yeah. Let's start on the journey on how Micro can share with you how we design, build, and run a cloud native applications. Okay, let's show that how many of you actually play MMORPG or RPG game before? Any of you play games? Or anyone or of you are very quiet and don't play at all? But never mind, let me share with you these analogies. So in a RPG games like Diablo, right, I have a paladin against on a knight with a sword and a shield. I'll use this analogy to share with you how these form the pillars of cognitive design. Right? So imagine the center portion is a knight, and then he has a sword and a shield. These actually form the three pillars of the foundation of cognitive. So for the knight itself, basically is a character, basically representing your application properties. So when you design your application in a cognitive way, so what are the properties that you want to have so that it can be or enjoy the benefit of being cognitive? Well, something like scalability. So you also see this in the definition. Loosely coupled, resilient, manageable, and observable. So these form the application property itself. Next, how about the score? The score is something you use to attack, right? So basically, it's some practices that allow you to enhance your application and perform in a very high performance, perform at high capacity, right? So some of the practices you can see is actually automation, continuous deliveries, and that's all. How about the shield? The shield is used for you to do defense, right? So basically, the shield from the cloud platform consists of cloud infrastructures, services, as well as the networking services that allow you to defend or to utilize it to defend against disaster, such as like your network failure or even disaster strike in the data centers. Yeah, so with this, we form the foundation of cognitive three pillars. So let's deep down into the night itself, which is the properties. So how can I design my application such that I can achieve these kind of properties? Well, I believe some of them might not be very new to you. Microservices architecture, it has been around for many years and it's not new, right? So I believe some of you, or most of you, have already know about this. Basically, microservices allow you to achieve scalability, resiliency, loosely coupled, and manageability. So let's take a look before microservices, we have a monolithic applications. So in the typical monolithic application, it's very simple, like what mentioned by Celine just now. You have a two-tier architecture where I have my user interface, business interface, then the data tier. And all these are sharing the same services and process. That's why it's monolithic and they are highly coupled. Well, microservices basically break down this monolithic or gigantic structure in different services as you see over here. So each services are run independently with their own processes and data, and is loosely coupled. So what's the benefit of breaking down all these things? Well, the first one, of course, it can be updated independently without deploying the whole system. The second one, it can be scaled based on demand. Of course, the one is the service is down. It's only that particular service. The whole system will not be done. So it improves your resiliency. So one of the typical example of doing microservices deployment will be the NEA WMS waste management system that Celine showed just now. You see there are so many services over there. Each individual services is running independently. So if you update one of the services, it will not cause the whole system to go down. It's just updating the particular services. So that's the beauty of microservices. So when we talk about microservices, we always have another thing in mind. Anyone want to have a guess? Or I think maybe everyone waiting for the break, right? For good food. Yeah. I'll share with you the term. So basically, containerization is another big word that work hand in hand with microservices. Because containerization also allow you to build application in a scalable and loosely coupled way. So let me share with you how containers look like. So from this diagram, you can see actually three containers. Basically, you can imagine them as a box that encapsulate the application itself or the particular service itself with the required libraries and runtimes. Underneath there's the OS over here. So by doing so, you can isolate the microservice and dependency from the underlying infrastructure, make it very portable and easy to deploy. So what are the good things of containers? Of course, I'll share with you in the later where I did bring up the SWOT. Right? Basically, the containerization and microservices help you to design your application or enable your design application to have all these very beautiful application properties such as scalability. While the SWOT is the practices over here. So one of the things I want to share with you is automation and the continuous delivery that you can make use of such practices using container orchestration tools. So container orchestration tools basically enable us to utilize the cloud services and through automation and continuous delivery to enable the same application properties. So you see this application property as scalable, resilient, manageable coming up again and again. Because in modern days of designing application, these are very essential properties. So what the container orchestration can do? Well, just now you have containerized, right? So everything is encapsulated and run independently. You need some tools to orchestrate that to make sure that you maximize or optimize their performance. So one way, of course, we use metering. And the other way, of course, you can also monitor their health. How healthy is the container? Or is it going down due to some issues? And you can also do a failover. You can also do updates. Right? So this is a powerful practice in that allow us to make our application in a competitive way, right? So benefit of containers, of course, the first one you can do auto scaling. The second one you can do auto deployment. Of course, the one is very portable, portability. Means that you can always shut it down this container and start a new one easily. So it helps you to do a failover or it helps you to recover from disasters. Like when you want to run the DR process, for example. Alright, so come to the next part, which is the last pillar, which is shield. The shield itself is a defensive kind of a mechanism. But over here, I'm trying to make this analogy to the cloud platform, where you have your cloud infrastructure, cloud computing, and cloud services. So, in nature, cloud platform itself is not very stable, but the cloud service provider, they are very clever. They create a lot of different services and tools for you to leverage to enhance the stability or resiliency of the applications. So even though it's not stable, but by making use of different services, it makes your apps become very stable and resilient. So example, so in GCC, actually we have like AWS or even Azure or Google Cloud. The cloud infrastructure, which is actually providing the compute services, instances, networking services like your compute or EC2s. Other services like your RDS, database, or even cache or storage is also readily available. So, what are the good things of utilizing all these services? Well, the first one that I want to share with you actually multi-AZ. In the multi-availability zone, basically it allows your application to be deployed in a high performance or high availability manner without doing the traditional way of setting up active and standby. Right? So if one of the AZ is down, then of course you direct traffic to the other AZ, which makes it very high available. So you can run critical application such as those services that public always accessing different type of hours, 24/7 with no issues. Of course, later team will share with you more on the multi-AZ approach. Right. Secondly, the storage, cloud service provider storage makes backups and archive much easier. So you can go to the console maybe with some clicks and set up, then you can set up all this rather than the old way you go down data center to really do backup yourself. Right? Now, of course, with all this in mind, what is actually happened is you can focus on designing your application functionalities, which benefit the public or internal users. Basically, they take away the worries or concerns on the infrastructure design or infrastructures, right? So we can be more focused. So this is the beauty of using a cloud platform. Of course, I very much want to end it here so everyone can go for a break, right? Not everything I share here is very perfect case. It's like a happy flow. Of course, not everything is so smooth, right? Not smooth sailing. We do encounter challenges along the way. From all our past projects, by building a microservices project and using a containerization, we do encounter challenges along the way. So let me share with you some of the challenges that we have faced. So the first one we have to share is on data dependency management. If this is not being taken care of, it can be a nightmare. Of course, the second one is how to deploy updates with zero downtime. And third challenge is on how to know what's happening in the microservices. So let me share with you one by one. So let's start with a very basic scenario over here. So basically, let's say you are the user and you want to get a list of all licenses from all organizations. So imagine these are licensing applications. So you want to do all these things. Maybe it's for reporting or just show on the table. In the traditional way, is quite straightforward. Your app just need to call SQL statement to the DB to get the information that you want. Although this SQL statement can be a bit complex that you need to do inner join, outer join, a lot of select. Well, for microservices, when we break down the architecture like this, which is we often see this in our projects, where we have a license service 1, organizational service, license service 2, and the UI service, where they are sharing, they are not sharing, and they are not sharing, and they're using a different database. Some of it can be on MS SQL, some of them may be on Postgres, some of them may be on MongoDB. So all different databases. So when they want to achieve the same result, how can we do that? Well, of course, one of the easiest ways is to do this in the app level by calling API. So I call API from all the services to get the data, then I join them to get the result to show to the users. So it's very straightforward. Of course, as the microservices number grow more and more, you get very slow. So many API calls will cause a lot of slowness. Now, we want to tackle this slowness problem. Maybe we don't do that at app level. We shift down to the database, right? Maybe we do a data replication because different licenses depends on the organization data. So I just replicate this to all the different database of the license service. Yeah, now I have a subset of the organization services. So when I call, I can get the data over here without using the organization service database. Isn't so I reduce the number of API calls over here, and then yeah, I solve the issue of slowness. But because of this, actually, indirectly we introduce a new set of potential issues. So what about updates? What if the organizational service there are some updates? Like for example, last time we were called Equerry, right? So now we become Toma Equerry. The name changed, so there's an update over here. Right? And then if there's an update, then isn't every time I need to update this subset data? So it becomes more and more complex over here. Well, maybe let's move back to the app level to see how can we tackle the updates. So we can same picture again. One way maybe we can use an update API from the organization. So whenever there's an update, we call the update API to get the latest data over here. Right? But then again, you are calling update one by one. So as the microservices number grow, then you encounter the same slowness issue again. And the organization service is not doing their original functionality, it's just busy updating different microservices. So this is not something that we don't want. Okay, so how about if this update fail? Let's say I can update fail. So will the organization service keep calling the API to update, or you have to wait or a few tries and just decide to give up. So it's very troublesome to handle that. So we don't want to do that at app level. Too troublesome already. We move it to the database. We try to do the data replication. So how to update data replication? One way maybe we can use the trigger to replicate the data. Right? But the problem arises again. If I use the trigger can do in the same database. And some of the services they are using different database. So in order to make this trigger work, I have to force all the different services using the same database, which will cause a coupling database level. So why microservices give me so many problems? Yeah, by just doing a simple things. Well, let's think out of the box. Maybe we don't do that at the app level. We don't do that at the database level. We think of something else. Okay. So imagine we have again the same field set of microservices again, right? What we can do is we introduce something outside of app and database. We introduce the event bus, which is run by we can run by Apache Kafka or even a message queue. So what this event bus do is the organization service who is supposed to do the update can publish the update to the event bus, and then the rest of microservices subscribe to it. So with this, right, the microservices will do what they're best at. Means that they run their own processes without seeing updating each other. So by doing such thing, any updates push the event bus will got pushed to the microservices that is subscribing to this event bus. By doing so, even if one of the services is down, right? When you started, you can continue to subscribe back to this event bus to get the latest update. So it's become the individual microservices responsibility to subscribe to the event bus to get the latest updates. So we sort of like release a lot of load from the organization services who publish the updates. Well, yes, we basically use this to solve the very first challenge. So hopefully it gives some insight to you if in the future of application development you encounter the same issue with microservices architecture. Now let's move on to the second challenge. This is you see this system will be down for maybe 9 and 4 minutes. Apologize for inconvenience. Very familiar. I believe a lot of websites we see that. In fact, I think last few weeks when I tried to access one of the agency website to do my own transaction, I do encounter that because I heard access it during one of the odd hour in weekends. Somehow we keep this inconvenience. Of course, in traditional way, it's not wrong. You need to break down the system in order for you to run the maintenance. But in modern era, as people getting faster and faster, and we have less patience, we do not want this to happen. Right? This become not acceptable at all. So imagine you have your Facebook, your Instagram, or LinkedIn. You didn't see their website publish such message, right? But yet the next morning you're accessing the LinkedIn again, you see there's something changed. Oh, the logo looks like differently. So how do you do that? Of course, one way to do is go through the rolling updates. So how can the rolling updates enable us to achieve zero downtime? So imagine you have a Kubernetes cluster over here, initially running 2 nodes of version 1 of your applications, where user is accessing it. During the rolling updates, the new version is being pushed out. And now user accessing both. Some user accessing version 1, and a small portion of users are accessing the new version already. Then you slowly shut down the version 1 by one. You push one more version 2 over here until all the version 1 is shut down and all the users are pointed to version 2. So this update is completed. Okay. Well, rolling updates can achieve zero downtime, but they do have their own limitation. The first one, as you see, because the node need to be shut down one by one, so actually it's a bit time consuming. And then at the point of time, you have both version 1 and version 2 until the whole update is complete. So this is, well, it works for some application, but for application that have a time sensitive features, then this may not work. Because let's say I need to push the features by 2359 or even 000 at 8 plus per day. If you're running rolling update, that means that even after the date change, right, you're still having old version and new version. For example, let's say in January there's a CDC voucher for 2023. For rolling updates, let's say I want to have the public to access CDC voucher, the new set of CDC voucher on the 3rd of January. If I'm running the rolling update during midnight, but after past midnight already, some of the user can access, some of the user can access. And some of the users very kiasu one, right? So they keep accessing. I want to get the voucher as soon as possible so that I can go and shop the next day. Then when they log in, they say, hey, how come I'm already 3rd of January, but I cannot get a voucher? Then become very angry. Then we go to Twitter, go to Facebook, and blast, oh, why this government, why like that? So to reduce the kind of incidents, to avoid this kind of complaint, then you cannot use rolling update, simply update. So what are the ways to do that? Of course, for today, we introduce you the other method of doing zero downtime deployment is using blue green deployment. So what is blue green deployment? So if you look at the diagram over here, this is your original version 1 application on this particular URL, which we call them the blue environment. So before we do a blue green deployment, we create a green environment, which is something like a duplicate or new set of environment. But the application version is version 2. We give them a different URL and have a new set or subset of testers to run some testing to make sure that there's nothing wrong with version 2. So during deployment time, because it's time sensitive, so let's say, okay, now is midnight 0000, deploy. Basically, just need to move the load balancer to point the application URL to the green environment so that the public now accessing the version 2 instead of version 1. So this is how blue green deployment is done. So of course, blue green deployment is not perfect either. Well, you also need to have some sort of complexity involved. So one of the limitations is because you have 2 environments being set up. So you need to have a duplicate license cost, duplicate infrastructures, which is very resource intensive. And of course, the cost is high as well. And then secondly, it's also quite complex to set up, especially if you involve database schema changes. Let's say if the schema changes only adding new column, then yeah, maybe you can do that because you need to ensure if anything happens, you are required to roll back to the previous version. So if you change the database schema, make sure that you need to support both the old and new version. So this is some example of the limitation of degree. Well, which type of deployment strategy you want to use? It all depends on your application requirement and the situation that you are facing. So there's no right or wrong answer. You just have to choose the one that fits your requirement, right? So the end result, all these updates actually can be configured automatically. So if everything that goes wrong, you can always go back easily. And of course, the main thing is do not affect user experience with zero downtime. So for user, this very seamlessly. Well, by doing such thing, I'm able to enjoy my holiday. Here comes to the next challenge that I want to share, which is knowing what's happening in microservices. In traditional approach, when you deploy, basically you just deploy the server, so you know the behavior of the application. If anything goes wrong, you can go back to these servers that you deploy. But in microservices, there are too many of them, right? It's like managing a flock of sheep. You don't even know by the name and they all looks the same to you. And some of them may lost something else, like the services got shut down. Some of them may join the queue and do auto scaling. So I give you a better illustration of this. In traditional approach, if anything wrong, it can be either F1 or F2. So you can look for it and troubleshoot. But in microservices, we have so many services over here. So it's much more challenging to find out what's wrong. And then, of course, during auto scaling, even worse, more microservices coming out. So how can I know what's the problem? Right? So in our approach, actually we share 2 principles over here. One of them basically is going through a monitoring. which you know what's happening. And then the second part, which is also very important, which is observability, where you can see which is the bottom of your iceberg, where you know why they happen. So it gives you a deeper understanding of the situation of your microservices. Of course, in the later portion, my colleague John will share more on how we do all these things in details. So I will not go too much on that. So save the show for later. So this is very important that I need to emphasize that I believe some of you have, or most of you actually know about the Titanic story. The captain only saw the top of the iceberg. He didn't expect the bottom of the iceberg to be too huge. That's why disaster happened. So the same thing over here, we don't want to have disaster happen. That's why the monitoring and the observability is required and to work hand in hand to avoid such thing happens. So let's come to the conclusion of let's revisit the three main pillars of foundation of the cloud-native design. Application properties, and then the practices, and then the cloud platform. With this design approach, we hope to enjoy the benefit of being cloud-native, being recover fast, to be scale fast, and then to have minimum downtime or zero downtime, can perform at quick loop, and of course, we want to roll out update really fast. And the final one, of course, to automate processes. So with this, I really hope I can enjoy a very stress-free, worry-free, and relaxed holiday. Okay, so then I will end my session over here. Thank you very much for listening. So I hope we not bore you and you can get some of the new information or insights for your next project. So before we move on to the break, I'd like to scan the QR code again if you don't know and enter the questions over here. Then we will answer you.